welcome to the session. Are we all settled? All right, so my name is Ravikant. I'm from Bangalore, India. So I'm a PowerShell MVP working at Dell EMC. So I mostly work on the infrastructure side of things. So I talk about DevOps, release pipeline, et cetera, but it's mostly on the infrastructure side of my business, right? So in this session, I'm basically going to talk about the infrastructure automation that we've enabled within our labs. I'll talk a bit about the background there. And then provide some concepts around what is that we exactly built and why we built it the way we built it, right? And then basically show you, in fact, it's actually the other way around. I'll show you the big picture first, then we'll go dig into the concepts. And we'll see what exactly is the path forward. Really want to open source almost everything within this project, but let's see how much I get approval to go do that. We'll definitely open source most of the stuff that you see there. All right, I'm also author of this book. I'm going to give away 2 ebook copies today, so just pay attention. All right. So the first thing, whatever we did, why did we even do that, right? As some famous person said, necessity is the mother of invention. So we had to find a way to basically validate the number of configurations that we actually go through in a release process for any of our products. So in this case, it's the storage spaces direct ready nodes that we develop at Dell EMC. Now, although there are only 2 platforms that a customer really sees in the market, there are actually hundreds of configurations that we validate inside the labs. Now, these configurations could be around the number of network configuration options that we have, like iWarp, Rocky V2, Mellanox, QLogic, and so on. It could be the number of drive configurations. We support SSDs, we support different NVMe adapters, and so on. So now, once we have these different configurations, it's up to the engineering team, that is us, to kind of go validate each and every configuration possible. But the number of people compared to the number of configuration, the ratio is not very good, right? So you cannot have people clicking on buttons and verifying manually the different things that they want to really test within the lab before the product is released. So now, with that challenge, what we tried to do was, what part of this entire automation or entire validation process can we automate? Right from the deployment to the end state validation. Now I have a 4-node cluster or a 16-node cluster. I want to deploy it in a completely automated manner. And at the end of the day, after the deployment is complete, I just want to see a report of things that were tested on this infrastructure and what is the status of each of that. Now that's just one pass. What happens tomorrow when I have a new firmware release from Mellanox, or my guys updated the BIOS firmware? I have to go through the same cycle again and again, right? So now when you put these things into context and put it in a proper deployment pipeline, what I really have is source control to the testing aspects and the final validation, just going seamless through the automation. Anytime I go check in or commit a firmware image, my entire automation kicks in again and then deploys the operating system, configures the cluster, runs all the test cases, gives me a beautiful report at the end of it. So that's the basic concept. Now, like I said, there are multiple configurations, right? That could be a spaces direct hyperconverged infrastructure. It could be disaggregated storage. And within each of that, I might have a system with multiple NICs. I might have a system with a Rocky NIC, a system with iWarp configuration, and so on. I have to handle each one of them separately. Now, this representation actually gives you a pretty high-level view of different configurations that we handle, right? Now, if you actually see this 3 nodes or N nodes here, OS deployment, host network are kind of common across all the nodes. Host network will have multiple configuration options within that, but you still have to do that. Whatever you see in the green there, the cluster configurations, spaces direct enablement, spaces direct configuration, etc., these are done on a single node. That's what we call logical configuration. It does not necessarily be applied on each and every system within the cluster. On just one system, you can apply it, and rest of the systems would automatically be a part of it, right? So within this framework, if I have to kind of identify a system with a specific personality, right? Don't confuse that with the cattle versus pets kind of a personality. This is more of an immutable thing, like I'll show you some in a few minutes. What we have done really here is decompose this whole thing into multiple components, and there's a configuration data which basically plugs into this framework and tells me what exactly the configuration that should be applied onto your system based on its personality. Okay? So here's the big picture, right? This is the kind of architecture that I have. Everything written in PowerShell, no other stuff here. So I have a configuration store, or a personality store for that matter, right? That's where all my DSC node configurations are stored. And I have a deployment store. That's where anything that is specific to a stamp, I'll show you what is a stamp, is stored there. That could be like compiled MOF files. It could be certificates related to target nodes. It could be an XML files related to the target nodes, and so on. And the image store basically has all the, the basic stuff that you require, right? Anything to do with your WinPE boot images, and if you want to do a native VHD boot, there's an image that is specifically customized for this entire purpose that will be stored there. Now, all of this actually goes through a build engine. In this case, it's invoke build, that you can replace with anything that you want. So once you have anything that is changing within the infrastructure, you commit a change into the framework. That's when the build engine basically kicks in. It starts to see if there is a need to rebuild the images like PE boot ISO or the host OS VHDX files itself and so on. It generates that, and it goes through a stamp manager, generates whatever is needed for the automated deployments like unattended XML files, and the certificates for DSC encryption and so on. All that is done. And using the BMC manager, BMC is basically the remote management module. Using that, we basically kickstart a virtual media boot on any of these nodes, and then the rest of the process is automated. That's the trivial part, right? Automating this part of the thing is very trivial. Few aspects that you see here in the stamp manager and the configuration manager, that's where the key is really. So that's what I'm going to talk about today. So I'm not necessarily going through the entire flow today, because if I start the build engine and invoke build, etc., all you would see is verbose log messages in CMtrace, nothing more than that. But instead, what I'll do is I'll double-click on each of the components, and I'll actually show you what goes behind the scenes there. Now, to some concepts here, right? What are configurations? How many of you have worked on or used composite resource configurations? Right? Very few. Okay. So basically, if you look at a DSC resource configuration, you have a resource instance with its instance parameters, or the properties, right? Now, when you combine multiple of them, for example, I had in the first chart, I had the host network configuration. What you basically do within a host network configuration on a hyperconverged node basically is you'll create a VM switch, you'll create the VM network adapters, attach them to the VM switch. If there is a VLAN configuration, you do that, and then essentially configure IP addresses, gateway, DNS, and so on, and then enable RDMA if it is required for QoS configuration and so on. Now, all these tasks, if you look at a DSC way of doing things, are very granular. Right? For every task, you have a DSC resource. For example, creating a VM switch, you have XVM switch resource. And then for assigning IP addresses, you have X network net IP addresses, and so on. Now, once you combine these things into a composite resource, you don't have to actually call each and every individual resource. The composite resource itself will take care of enacting these other combined resources on the target node. Let me show an example there. Now, if you see this, thank you. Where is it? Better? All right. Not sure if you can see at the back, but this is a composite resource module that I created for Hyper-V configurations. If you actually go into the resources here, you'd see that there are 3 different types of resource configurations as composite configurations available there. The first one is, let's say, Hyper-V switch embedded team. If I go into the resource definition itself, all right. So it basically combines multiple of those resources into a single composite resource module. So I have the VM switch, VM network adapter, and so on. And this is a parameterized configuration. So I basically have parameters that are being used within the resource instances there. Now, instead of calling each and every individual resource in my DSC enact process, I'll just call this composite resource with whatever parameters that I want to. So also I have some predefined parameters there, or with default values. So these default values basically, if you understand the free-form versus known configuration pattern, free-form configuration basically says that everything that you want to put within resource instance configuration should be parameterized. But that could result in hundreds of parameters for a single configuration, given the number of resources that you have in the resource configuration document. Whereas using the known configuration pattern, what we do is, for some of the values that you want to really restrict configuration to a certain value, we put the default values for that. Now, on all my nodes, I don't want the teaming mode to be changed to anything else. So I kind of put it to switch independent, but at some point in time, if I really want to change it for some reason, I can use that teaming mode property and then change that to a different thing, right? Similarly, the other things like, what kind of a management adapter name I want to give it, etc. So once these are packaged, what you essentially get is something like this, right? Let's say configuration C1 is about host network. It combines all your aspects of creating a VM switch, creating network adapters, assigning IP addresses, and so on. All I have to do is just call C1 with the right parameters. It will do the host network configuration for me. Okay. Next, C2 could be configuring QoS or DCP parameters on the system. Right. The C3 could be just maybe a domain join configuration. All it does is rename the computer and join the domain, etc. Like that, I have multiple of these resource configurations here as composite resource modules. Like I said, they are not simple DSC configurations. They're packaged as composite resource modules. With that, I can simply use the composite configuration also, but since I've packaged that as a resource module, I'll be able to discover them using get DSC resource commandlet, right? And they're, of course, reusable. I can reuse these configurations between multiple different personalities. And these are not just configurations, they also cover the entire deployment pipeline. By that what I mean is really, within the infrastructure deployment pipeline that I have, before I start the deployment, I want to validate the infrastructure for its applicability, right? For example, if I'm trying to deploy a HCI node, I want to make sure that virtualization is enabled on that particular system. Without enabling virtualization, I don't have to really go configure a HCI node, because hypervisor is pretty much required there. So there's pre-deploy validation, and then once the deployment is complete, the operating system and so on, I run some more test cases to ensure that this particular node is ready to become a cluster node, making sure that the cluster role is enabled, making sure that it has the same number of drives as compared to other systems in the infrastructure. Once this entire deployment is complete, I'll do some more validation after the cluster automation is also complete. I will run some more test cases to ensure that it's really functional, right? Of course, I'm using DSC here, but a resource coming into desired state does not necessarily mean that the system is functional, okay? System functionality is different from the desired state of a resource. So that's where we basically run some kind of functional testing. For example, once this entire cluster is built up, I really want to move virtual machines, create virtual machines, move virtual machines from one node to another node, make sure the live migration works fine, make sure I can create the virtual machines, create VM switches, create VM network adapters, and so on. The functionality is not broken. I validate that. Once that piece is done, I put this entire infrastructure into operations, and every night or every week, we kind of run some operational validation tests on the specific system, which will basically monitor the health of the system itself, right? And every night I get a report of, let's say, this is what has been run on the system, this is the health of the cluster, okay? So essentially, the resource configurations combine all these things. To that extent, I had this project called Infrastructure Blueprints. A lot of content from there is actually used here as well. And this is on GitHub. So if you actually go here, you can see the diagnostics folder within each and every composite resource module. That's where I have the test cases. The comprehensive test cases are what that run both after the cluster deployment, like functional validation as well as operations validation. Let's quickly see another demo here. So one of the things, like I said, for a HCI node, I really want to make sure that my system is on par with the whatever required configuration that I need in the BIOS or other configuration of the bare metal system. So for that, we have kind of a reference JSON, which will basically look something similar to this. I guess it's wrong. So this is kind of a baseline that I have for my system configuration. If you see here, somewhere in the BIOS configuration, I have things like proc virtualization should be enabled. On all these nodes that I'm going to test, the processor virtualization should be enabled. Now, the way I test it is using a pester script. Just run this. Give the credentials for my BMC access. So then what it does is basically connects to the remote system. It has a SCP JSON. We call it a server configuration profile. It uses that as a reference and makes sure that it validates each and every attribute present within this JSON against the reference system or against the target system. It just takes a bit because it has to connect to the remote system. Sure. Okay, sure. Thank you. Yep. All right. So, like what you have seen here, it went through each and every component within my system. Like the iDRAC is a remote management controller, and then the BIOS settings here. It actually validated everything on the target system to a reference property that we have within the server configuration profile. Right? So this is what runs as a part of my pre-deploy validation. So now once we have these configurations, for example, what I'm trying to show you in this demo today, I have these two modules. This is the different composite configurations I have. The system onboarding one, which will basically do some firewall configuration. It'll do the IE security settings, etc. There are two different types of host network configuration that I can perform. It could be a fully converged VM switch, or it could be for our disaggregated infrastructure. I'll show you how we use all those aspects. The second one we have is the cluster configuration. And within that, I have these composite resources. We first start with the create cluster composite resource, then add all the cluster nodes. Once the cluster is created, then we go enable cluster S2D, and then we create a file share witness, configure a file share witness for this cluster. So everything done through DSE here. Right, so the second aspect I talked about is the personality, right? Personality is something that combines these configurations into a single entity that gives the identification to a bare metal system. So, for example, when I combine C1 to Cn, I get a HCI primary node. That's where my cluster configuration has to be performed. Right? Apart from doing the general configurations like host network configuration, domain join, and so on, we'll also run the cluster configuration aspects there. There'll be a participant node on which all I have to really do is configure the host network, join it to the domain, and then make sure the primary node adds it to the domain, or the cluster, rather. Now, these are two different personalities I have. Whenever I have a bare metal system, I can attach one of the personalities to that. In this case, let's say the primary node can be only one, right? The participant nodes can be n, based on the cluster size. Now, once again, don't confuse this with the pet versus cattle thing. We're not giving an identification per se. We're actually giving it an immutable personality. When I say immutable personality, when I want to update any configuration within the personality, I just rip off the server, redeploy it. I don't really go update any DSC configuration, or rather any configuration on that system anytime. So, quick demo on the personalities. If you actually see, I have a few personalities here already created. There is a S2D HCI is a hyperconverged infrastructure personality, and DAS is a disaggregated storage personality. Let's go to the first one here. To start with, we have to, of course, manually define what is a personality, right? I cannot really automate this aspect of it. I have to define the personality manually, which is like, in this case, let's go to the primary node first. So the primary node that you see here basically says, what are the different configurations that are a part of this personality? Now, what is that I'm packaging as a single personality? I have the system onboarding, you have seen that, and this is a HCI cluster. So what I have is a host network fully converged set as the host network configuration for this. And of course, the other things like RDMA configuration, QoS configuration, and so on, and later domain join, etc. And since this is the primary node personality, I have the create cluster, add cluster, and so on again, like I showed in that particular slide. Now, what you also see here is this particular property is set to true. It's a singleton personality. I can only use it once within the stamp. I cannot have multiple instances of this personality within a single stamp. Okay? There is also an order here. For several of these configurations, it is set to 1. But if you actually see the create cluster to the rest of the configurations, it is set to 2. It is used internally within the tooling, where when we have to orchestrate this thing end to end, we kind of basically say, orchestrate the order 1 configurations on all the nodes first, and then come to the order 2 configurations and orchestrate that. So that way we kind of avoid any cross-node dependencies, right? So this is the primary node. I know what has to be enacted at the end of the initial system onboarding process. Now, once this definition is done manually, what we have is something like a configuration manager module, which basically can play with these personalities. It can look at the host configurations or the composite configurations, understand what parameters are required to make that configuration happen, and generate some kind of a personality parameter file. So let me just load this module. There are some unapproved webs, that's fine. So what I'm doing is I'm trying to generate these parameters for a different personality. That's for the disaggregated storage. If you see here, I just have the personality definitions here and nothing more than that. Okay? Let's go generate the personality definition for the first one. So in this case, what it basically does, it uses the get DSC resource. Like I said, the composite resource modules become discoverable with get DSC resource. It goes to that, understands what all parameters are available within that composite configuration. And on top of that, what it essentially does is it goes and understands what are the default parameters, what are mandatory values for each of those parameters, or if there are things like, I don't think you'll see it here, if there is a validate set, for example, when I'm configuring load balancing algorithm, it can be either Hyper-V port or dynamic. So you get all those parameter values also by looking at the composite configuration itself. We do AST of that. We use AST to go parse the configuration document or the composite configuration, and then retrieve all those values and bind them here within this. So that's what you basically see here, right? For the system onboarding task, what is the module that is being used? That's a composite resource module. And what are the parameters that are required to use that? It also says if it's mandatory or not. There's a type which is attached to that, and there's a default value there. Similarly, we basically find out for each and every configuration that is available within the personality, we generate this script. We generate this kind of a parameter JSON. Now, once that is done, what we have to do is basically generate a configuration document itself that uses these composite configurations. The configuration document is nothing but a .ps1 file, which basically has, again, some of the parameters and etc., and uses the configuration data and so on. So when you use a configuration data, you basically go with $allnodes.node name and then all those aspects of it, right? Let's quickly see that as well. Right, so that thing generated. So if I go here and observe this, I had, for a specific personality, which is the primary node personality, I had order 1 and 2, right? Order 1, which basically executes on all the nodes in parallel. Order 2 is what happens at the end of the initial onboarding process. So there are two different configuration files that are generated for it. If you see the first one, any of the credential aspects, we kind of make that as a parameter on the configuration document itself. Rest everything is expected to be driven through the configuration data of the DSC document. So this gets auto-generated with all these variables set in place. All you have to really do is, at this point in time, use configuration data, or you can manually generate it, or there is tooling that does that as well, right? You can generate the configuration data from a stamp definition, and then compile this configuration to a MOF. Then you will be actually ready for the entire enact process itself. All right. And you can also see within the configuration document, you'll see that there are multiple depends on if there are. Let me see if I have another document for that. So basically, the dependency resolution is also done as a part of this, which is, again, driven from the parameters. So this is a one-time job. So what we basically do is whenever we create a new personality definition, we kind of commit it to the personality store. And there's a build task which triggers immediately, generates all these configuration documents for us, right? So these parameters and configuration documents are always available within the store. So whenever you want to create a new stamp, these are the files that are referenced. Right. So the next aspect here is the stamp. Should be clear by now, right? You basically combine multiple personalities to build stamps. Now, this whole thing is a stamp. Within that, I have 3 nodes. One is the primary node. Like I said, it's a singleton, so you can have only one instance of the primary node. And there are 2 participant nodes which have a similar configuration. Of course, the configuration data is what makes them different. So IP addresses on all these servers and the node names, etc., will all be different for any of these nodes. That's achieved through the configuration data. Let's look at that as well now. So there's a module which basically takes care of this STAMP deployment itself, the orchestration aspects of it, apart from the build engine. So I have the BMC manager. I need that to gather some details about the bare metal servers. Let me just grab the credentials. And that's the BMC credentials to connect to the servers that I have. Now, at this point in time, there's something called a new node manifest. What you essentially see here is, for a given personality, these are all the parameters that you have to supply to the configuration documents to make the configuration happen. Now, this is a lot to manually type it. So what we have today, I would say this is a stopgap. I'll show you something else in a bit. If I do something like this, I have the S2D DAS, and then personality name, quickly copy this. So once you provide these two parameters, you get the dynamic parameters added to the function itself, so that anything that was there in the parameters.json that we just saw gets picked up here, along with its default values, along with its validate set and so on. Thanks to Bartik for the tip. I was struggling to make this happen. There was a simple thing that I had to change, actually, type I had to use that actually make this happen, right? So all of the other parameters that you see here, everything gets automatically generated as dynamic parameters. Anything that has default values, you don't have to necessarily provide that. The scripting internally takes care of adding them as default values for the things that are omitted as a part of the node configuration. So let's run this. And these are some things that are never used by an end user as such, right? This is all inside the tooling, internal to the tooling. Now, this is all called within the build scripts automatically. So you never have to really define any of these things manually here. So let's just create the node definitions first. That'll be faster. The new stamp, which is another function that we have, basically combines the two node manifests that we have into a single stamp. Okay. So what it internally does is it takes this whole thing, and if you actually look at the manifest JSON, each one has node data and what are the different stamp personalities that you plan to use within this stamp, and go to a specific node. It adds some identifiers, extra identifiers, like what is the service tag of that node, so that I can identify that specific node as a part of my bare metal process. Within pre-OS, if I have to identify what untitled XML has to be copied, what certificates have to be copied to the node, etc., we use these identifiers for that. Essentially, it basically combines whatever parameters that you provided within the node definition into a single manifest, right? And from that, we kind of generate the node certificates. It's a self-signed certificate for DSC encryption. We just store that and apply it on the target node at the end of the enact process, or in fact, the imaging process. So this is another pretty interesting piece here. What we do is we have all the data relevant to performing the deployment itself at this point in time, like all the parameters that are like computer name, what domain to join, etc. Now we generate the configuration data automatically out of that, right? So this command does that. So that gets stored in the deployment store, the configuration data here. Right. So if you see this, We basically define what is needed. For example, PSDAC allow domain user is required because I'm using domain credentials to go join the domain and for cluster admin accounts, etc. There's a certificate which was generated. I use that for encrypting all my credentials. When I use this configuration data with a configuration document that I just created, when I compile it, all my configuration credentials will be actually encrypted when the morph is generated, right? And all other parameters that are required for the node. So in this case, I have only two nodes. One is a primary, one is a participant node. Otherwise, you would actually see, for a participant configuration, multiple of those nodes listed here. At this point in time, we can simply generate the unwritten XML. Generating the unwritten XML takes place, again, in the deployment store. You see these XMLs that are generated. Now, this kind of gets used within the deployment process itself once the deployment is complete, or the imaging process is complete. We just drop this unwritten XML onto the hard drive, reboot the node, and the node automatically picks up this unwritten XML and then completes all the out-of-the-box experience and whatever initial commands it has to run. And this is how you basically compile the configurations. I think I have the configurations required, yes. Hope it works, yes. Right. So the entire process, the only place, two places in fact, where there was manual intervention was basically first defining the personality, which is one time, and then defining the stamp itself. Defining the stamp itself has to be done manually, right? Because you have to identify node, what personality it has to be in, and then create the entire stamp definition. Those are the two manual aspects that we have. And at this point in time, once the stamp manager completes all these steps up to now, like generating the morph files itself, we bring in the BMC manager, which will attach a PISO that was created as a part of the image build process to the target node. Hope it works. This thing takes a bit of a time. Well, it's running. I'll explain the flow here. So once that is done, we go set the server to the power on state, which automatically boots into the PE boot ISO, completes the entire imaging process, grabs all the configuration documents as morph files, goes into host operating system, and then finishes the LCM enact process so that it uses the certificate that was generated. Let me quickly show you that. That's a simple script. Since we already have all the artifacts required for it, it's going to be very easy to do that process. It in fact happens in this host OS start. So we copy from a share that was available, and then bring in the certificates, import the certificate, enact that LCM configuration. So by the end of the host OS process, what you basically have LCM in ready state so that you can actually remotely push the configurations. So this is sent to the deployment station as status. So once the orchestration engine or the build script finds that a specific system is in ready status, it will actually start enacting the whole configuration itself. That's in the order, right? All the order one goes first, and the second order will go after all the initial configuration is done. It's still running, that's okay. Right. Now, so what you're seeing in the new node manifest is quite lengthy, right? I mean, each command I had to new node manifest and specify each and every parameter there. What I'm basically looking at is a DSL. That's still ugly. I don't say it's super, but what it'll basically help, so it'll look something similar to this. It's still in work in progress, so I can execute. There was nothing right will happen there. Okay, so with the DSL, what I can basically achieve is separate out all the common properties from a node specific data into stamp. For example, each and every node requires those BMC credentials, domain name, domain join credentials, and the network adapters that I'm going to use to configure switches, etc., will be all common. And then there will be the adapter names and the product keys, time zones, etc. Everything will be common across nodes. I shouldn't be putting that in a node-specific configuration data. So the DSL will actually separate that out into a stamp definition. And then for the node parameters, for the primary node, you might still have something more there. But for the participant node, see how it gets reduced just to that aspect of it. Right? Now I can add multiple nodes like that, and when I execute this entire DSL, it will go invoke the deployment from end to end. The second aspect is be able to move this whole thing to a NoSQL database kind of a thing. Since I already have a JSON store that I'm using right now, it's easy to move these JSON configuration files into a NoSQL database and use that as a persistent store. Right? So that gives me multiple advantages. I can layer a REST API on top of it, and then have these configurations automatically build from other management consoles that I have. Of course, automate documentation. I'm going to attend the workshop today to see how exactly I can use PlayTPS to kind of. We have written a lot of Markdown files for all these things. How to use some of the commandlets like new node manifest and new stamp and so on. What exactly they have to look for, and etc. Now, as a part of the build process, I have the configurations also each going out with Markdown file describing what is that configuration, whether it's composite or the granular configuration that I have. The idea is to basically compile this whole thing into a reference guide using one of these automations that's possible here. Right? So that way, I don't really have to sit with people and explain what exactly needs to be done when I add a new personality or when I add a new configuration. Once I move to the NoSQL databases, I can layer some kind of a REST API on top of it. Could be Polaris or Universal Dashboard. I played with Universal Dashboard a little bit, so feel comfortable doing something in PowerShell rather than going to something else. Polaris is PowerShell implementation, though. It's coming up, at least. Right? So that gives me another way of, like I was saying, integrating this whole thing into a different management console. Right? We have, for example, SCVMM. From SCVMM, if I want to trigger this entire deployment, having a REST-based method will be quite easy for me to go gather the data and then start the entire init process or the deployment process itself. And of course, reporting. Today, everything is, whatever test cases that we run across the deployment pipeline, whether it is the pre-deployed test cases or the functional or operational test cases, everything generates its own HTML file. I want to really see how we can use the NUnit XML that Pester gives us and maybe play with that a bit so that I can generate, put that back into a NoSQL database from a deployment point of view. So at any point in time, if I have to go query for a specific deployment, when it happened, how it happened, and what happened within the deployment, I should be able to gather all that data, telemetry basically, through my reporting dashboard itself. All right, so how it really helped us, we're able to now add multiple configurations seamlessly. I can create new personalities. Tomorrow I want to test a different network adapter vendor or a different network interface itself or a different network configuration. Today, if you have seen everything was probably tagged with VLANs and so on. Let's say if I want to do untagged VLANs for the storage or management networks, etc., all I have to really do is create another configuration, plug it into the personality, I should be ready to go, right? So, and also, it's done in a very modular way. There are interfaces that are talking to each and every component within this, right? For example, BMC Manager. BMC Manager, what it does essentially is power on, power off. It does attach media, detach media, so on. Now, if I have to do that on a Hyper-V system, I can use the same interfaces with a virtual machine also. virtual machine power on, power off, and then attach ISO, detach ISO kind of a thing. If I have standardized on the interfaces, you can plug in a VMM manager or VM manager module kind of a thing, and then have this entire deployment take place on a single host within virtual machines. You don't necessarily need bare metal systems in that case. Right? So it kind of becomes really pluggable out there. All right, questions? That's all I had.
So you define two phases, right? Phase 1, phase 2. You push in the configuration in phase 1. How do you keep track of the status, and what if it fails before you move to phase 2?
Yeah, so what I've not shown you guys is, so the question is about how do we track the progress of phase 1, that's the order 1, and then the proceed to order 2. So what I've not shown you is the orchestration piece of it. That's where the build engine really comes into play. So like I said, once the host OS deployment is complete, it'll actually send the status back to the deployment station. And the deployment station at that point in time triggers the configuration enact process. So it identifies the order in which it has to do. Now, once the order 1 is sent, it'll keep checking for the get DSC configuration status and basically the desired state on the remote system. Once it achieves the desired state, it'll wait until then and then push the second configuration. So everything in order 1, for example, if you have 10 nodes in the cluster, all order 1 has to come into desired state before order 2 can be executed.
So you have fully consensus?
Yes. So all order 1 happens in parallel, so it's not really too time consuming though.
Earlier on, I saw a command that you were creating a certificate.
Yes.
Is that self-signed? Is that named?
Right now it's a self-sign. It's a self-sign certificate. Yeah, I mean, this is a lab environment. I can actually request from the lab DCs itself, but I chose to do it using self-sign because this is only temporary phase, right? I don't necessarily need those certificates after my deployment is complete. I don't need, because we knock off all the DSC configurations once the deployment is complete. We don't track the DSC state itself after everything is successful. Yes, Ran. Yeah, that's a very good question. So the question is, why would you necessarily need DSE if I'm not using DSE as after fact, right? So DSE gives me the flexibility of decomposing the configurations, right? That's the first aspect. Second, I get to resume something that failed with DSE. I can, of course, would have done this whole thing in ad hoc scripting, but I have to handle things like idempotency. If I have to restart the configuration process after a failure, I'll have to take care of it myself. But using DSE, I don't have to really worry about it. If I have 10 nodes, one node fails within the order 1, all I have to do is just go rerun that particular node, DSE configuration, come back, and do the order 2. So why I'm not using after fact? I don't necessarily need it. At that point in time, I'm not tracking the DSE desired state itself as a functional state. Like I said, system being in the desired state does not mean it is functional, for me at least, right? So for me, the functionality really depends on what I really want to test on that infrastructure. So, and DSE definitely brings the system into desired state, but the functionality testing itself has to be done outside of it. Yes? All right, the question is, where am I using Pester? So if you have seen the pre-deploy test cases, where I was actually checking for the bare metal configuration, whether it's up to my baseline or not, that's where Pester was being used. So like that, there are multiple phases. Once my order 1 configuration is complete, before I start the order 2 configuration, which is cluster, I basically test all these nodes for readiness to join a cluster. Right? All those aspects are taken care of using Pester. Yes?
So you mentioned that you use Pester to test if the cluster nodes are in desired state. So what you do or not? Do you wait forever, or do you have some other method to make them so?
Yeah, so the question is, let me repeat that. So the question is, I'm using Pester for checking the functionality before deploying the cluster itself. So what if the system is not functional or ready for the cluster deployment? Very good question. So I trigger that, I flag it, and leave the system there. Because what we are doing essentially is not a check for desired state. What we are checking for is functionality itself. So the functionality cannot be rectified unless there is someone actually monitoring it. Any other questions? All good? Yep.
Do you have kind of a reverse way to build your configurations from an existing system?
I don't. Never thought about it. Yeah. Because these are things like done in a lab. So that's a good point, though. What we basically do today is identify configurations, convert them to composite configurations, and build personalities. So not the other way around. So, yes, sir.
When will your book be published?
It's already out. It's available for pre-order. You can order it maybe next week onwards. It's just went for print. There's an ebook already. I just have 2 copies, and there were so many questions. I was hoping that I'll just give it to people who ask questions. So, yeah. Okay.
You were saying how you run the function tests in Tester after the fact you don't rely on DSC test. Would that not be an argument that the DSC resources aren't written correctly?
No. That's what I'm telling you, right? DSC resource bringing the system into desired state does not mean that the system is functional. It has created the VM switch, right? It has created the VM network adapters. It has assigned the IPs, everything based on the configuration data that you specified. But end of it, what is the guarantee that the configuration data that you specified is correct? That can be validated only through a functional test when I try to reach the DNS, for example. When I try to create a virtual machine, ensure the virtual machine can connect to the host operating system through internal network adapter or something like that. And then they both can talk to each other. Or 2 virtual machines on 2 different hosts can talk to each other. That's the functional testing aspect of it, which DSC will never be able to tell you.
So basically, the test will be the validation whether the configuration the user, the operator, put in was valid.
Correct or not, yes. So at that point in time, if the functional test itself fails, he has to rectify the configuration and come back. And of course, it is all idempotent, so it will go just change the configuration if it is required. Anything else? All right, now the tough task. Who should get the book? You should get it? Yeah. No, that was not a question, sorry. Okay. So let me see who paid attention to the scripts I was showing. So what was the command that I used to connect a virtual media, the boot PISO, to my bare metal server? I know it's tough, but yeah, if you can recall it, you definitely deserve a book. So, no, sorry? Something close, yes? No. No. It is attach PE server virtual media. You get it. You're close, you get it. The second one goes to Ryan. Yep. Thank you.